All right, so today we're looking at metamorphic rocks and the rock cycle. Okay, so we looked at igneous rocks. It said igneous rocks form from magma or lava cooling and hardening. That makes it igneous rock. Sedimentary rocks, for the most part, form from little particles being cemented together. Metamorphic rocks form if I take a pre-existing rock and I expose it to heat and pressure. It can create a new rock. Now, not enough heat to melt it, because if I added so much heat that I melted it, I'd get magma, and that would just become a igneous rock. But if I heat it up close to the melting point temperature, what can happen is characteristics of that rock will change, so much so that it's considered a new type of rock. Or pressure. If I apply enough pressure to that rock, some of the internal characteristics of the rock will change, again, so much so that even though it's made the same stuff, but the stuff's been kind of rearranged by that pressure, will be considered a new type of rock. So there's basically two types of metamorphism, regional metamorphism and contact metamorphism. Regional metamorphism, also known as dynamic metamorphism, forms during mountain building, and it produces a lot of metamorphic rock. So there's different ways in which mountains form. Some mountains form from volcanic activity. Another way in which mountains form is I could have rock layers like this, and these rock layers could be pushed together by pressures in the Earth's crust, and the rock layers could be bent upward like that to make mountains that way. All right. Now it takes tremendous amounts of mountains or tremendous amounts of pressure to push, miles upon miles of rock up several thousand feet. So much so, not only does it push the rock several thousand feet up, it also changes the internal characteristics of that rock. But it's not just a small amount, it's gonna be like a whole mountain's worth of metamorphic rock. So regional metamorphism produces a tremendous amount of metamorphic rock. If you've ever been in the Adirondack Mountains, most of the rock up there is metamorphic rock for that reason. All right. Now, during the regional metamorphism, the pressure squeezes the grains closer together. That pressure squeezes them closer together, changing the characteristics, and also the ions get rearranged to produce new ones. So basically that means is that it's still got the same stuff in it, but the stuff is arranged differently. Okay. So that's regional metamorphism or dynamic metamorphism. The other type of metamorphism is called contact metamorphism or thermal metamorphism. That's when I have hot lava or magma comes in contact with other rock, and the heat from that magma or lava is enough that it changes the original rock. So how you get contact metamorphism is, let's say I had some rock layers like this, and I had sandstone. Remember, sandstone is represented by the little dots. And then I had a layer of limestone. All right. So deep down in the earth, there's magma down here. Some of that magma starts working its way to the surface, but it stops before it gets there. That's called an igneous intrusion. So it might be something like that. All right, so this is magma. When this cools and hardens, that's going to be an igneous rock. Here I got sandstone and limestone, which are sedimentary rocks, but there's going to be a spot where this hot magma touches the rock that's already there, and what's going to happen is that heat from that magma is going to change that rock. So all the way around it, I'm going to get this little zone of what's called contact metamorphism. All right. Where the heat from this magma was changing the rock that's already there. So like quartzite, when it's exposed to heat and pressure, turns into a rock, sandstone, when exposed to heat and pressure, turns into a rock called quartzite. So here's sandstone, here's the igneous rock, there'd be a little zone of quartzite all the way around it. Limestone exposed to heat and pressure turns into marble. So here's limestone, here's the igneous rock, right there would be like a little zone of marble right there. Okay. Now, since the only place that you're getting the metamorphism is just that little zone all the way around the intrusion, compared to the regional metamorphism, contact metamorphism produces a metamorphic rock on a small scale. So it doesn't produce a lot of it like the regional metamorphism does. All right, so now, some of the characteristics of metamorphic rocks. I will show you those on the projector over here. So, and that's a chart that I'll show you in a couple minutes. All right, so before we do the characteristics, this is an example of one of these places where I'll get contact metamorphism. All right, so the black stuff's the original rock, and this here, you can tell that it's a different type of rock. It's a different color for one, and this has much larger crystals that this does not have. All right. So right here, the heat from this, when this little finger of magma was working its way up, is going to change the original rock over here. So all the way around, now it's hard to see because this is black, so the original rock and the metamorphic rock it turned into are going to look very similar. But all the way around this igneous intrusion right there is going to be a little zone of metamorphic rock. All right. So all the way around it. All right, so this right here would be the igneous rock. Here's the original rock. Then right there would be a little zone of contact metamorphism. So again, it doesn't produce a ton of metamorphic rock. All right, now, some of the characteristics that you find in metamorphic rocks. All right, first off, got a characteristic known as banding. So banding kind of looks like this. So key things you should notice, it's kind of like light and dark wavy lines going across the rock. There's usually a significant difference in color. So there might be white and black, or pink and black, or pink and brown, something like that. The bands, if you notice, their thickness can vary quite a bit. It might get thicker and thinner. They're kind of wavy in shape. And if you notice, a lot of them only go partway across the rock. Right? So that's kind of what it looks like. If you look at actual banding, so right here I have some actual banding in a rock like there. Right. So there's some actual banding. Another example of actual banding is right here. You got the darker kind of blackish stuff and the kind of like a dark orange color right there. There's some banding right there too. Here's another one. It's got banding. It's a big one. Here I have the banding, but what also happened in this one is the pressure that created this also caused a bunch of distortion. So in this particular rock, there's lots of distorted banding on it. Right? So that's what banding looks like. Banding and banding with distortion. Right. Another characteristic that metamorphic rocks can have is foliation. So basically what happens with foliation is I have crystals that get experienced a lot of pressure, kind of squeezes them together. So afterwards it kind of looks like that. So they basically kind of been squished this way from the pressure. So foliation basically is flattened crystals. Sometimes a rock might have a platy or a rock's crystals might be platy or flaky in appearance. Okay. Another characteristic a rock could have that's undergone metamorphism is here's the rock, I expose it to a lot of pressure. It squeezes the rock together, but the rock still has the original mass, so it gets squeezed together in maybe this size. Now this, if this was the result of this squeezing together, it still has the same amount of mass in it. What's different about it is the volume. All right, so it has the same amount of mass but squished into a smaller volume. This is going to be more dense. So a lot of metamorphic rocks are more dense than the rocks they came from. Another feature metamorphic rocks can have is they can be more crystalline. So I could start off with something like a sandstone. I got a bunch of individual sand grains that gets exposed to heat and pressure, and those sand grains kind of morph into quartz crystals. So it can end up with something like that. So notice there's not the gaps between the sand grains anymore, and they're not roundish. They've kind of turned more to like an interlocking crystal kind of look to them. It's the same chemical composition, it's just been turned from individual grains into crystals. Now, like these guys right here, this is limestone and this is marble. So the limestone's kind of dull and earthy. When it turns into the marble, I can move it around like that. You can see it all sparkly and stuff. That's because the marble has crystals in it. All right. So this is more crystalline than this is. All right, so it'll become more crystalline. All right, so those are the main characteristics with metamorphic rocks. Now, in your reference tables, you got a chart right here for metamorphic rocks. And what this shows you is here's the various names of some common metamorphic rocks. Right here, foliated. So these are the foliated metamorphic rocks. They have flattened crystals. The non-foliated, these don't have flattened crystals. Bandings right there in the chart. Got the grain size, composition. So these guys usually have a lot of minerals in them, a lot of different types of minerals in those guys, where the non-foliated ones typically have a more uniform composition. So quartzite just has quartz in it. Anthracite coal just has carbon in it. Marble just has calcite or dolomite in it. So it's more set composition. Type of metamorphism, regional or contact. Remember, regional is the one from the mountain building. Contact's where it just comes and touches lava. These guys here could be formed by either of them. Comments, it tells you some other information about the rock. So some of the things it tells you is what turns into what. So metamorphism of quartz sandstone. So if I have sandstone exposed to heat and pressure, it turns into quartzite. Metamorphism of limestone or dolostone. So if I had limestone exposed to heat and pressure, it turns into marble. Metamorphism of bituminous coal turns into anthracite coal. All right. Now up here, it works a little bit differently though. Here it says low-grade metamorphism of shale. So if I take shale and expose it to some heat and pressure, it turns into a slate. But if you look here, it says heat and pressure increases. So if I take that and expose it to more heat and pressure, it turns into a phyllite. Exposed to more heat and pressure, it would turn into a schist. Exposed to more heat and pressure, it would turn into a gneiss. So a gneiss could form from just a shale that's undergone a lot of heat and pressure, could turn into a gneiss. Where less heat and pressure might turn into a phyllite. Right? So that's one way in which gneiss forms. Another way that's actually not in this chart, if I take granite and expose to heat and pressure, it could turn into gneiss as well. All right. And lastly on here, the map symbols. A lot of times on maps and diagrams, instead of writing the words out, we'll just use symbols to represent the rock type. So those are the map symbols right there. All right. Now, one other chart I want to show you kind of dealing with this. Is this rock cycle chart from your reference tables. Now what this chart shows you is how you can get any one type of rock from any other type of rock. All right. So like if I had an igneous rock exposed to heat and pressure, I can get a metamorphic rock. If I had a sedimentary rock exposed to heat and pressure, I can get a metamorphic rock. If I have one type of metamorphic rock exposed to more heat and pressure, it could turn into another metamorphic rock. All right. So it shows you how you can get, so if I start off with igneous rock, expose it to weathering and erosion, I can get sediments. If the sediments get deposited and buried and compacted and cemented, I can get a sedimentary rock. Exposed to heat and pressure, I can get a metamorphic rock. If I melt the metamorphic rock, I get magma. If the magma cools and solidifies, I can get an igneous rock and then back to where I began. So you can follow these arrows and you can get any one type of rock from any other type of rock if it goes through the right processes. Now, a nice thing about this chart is a lot of the key terms that you would need to know to how rocks form, you don't really need to memorize if you have this chart, because if you had a question like what processes make sedimentary rock, you just look at this chart and like, oh yeah, it's the deposition of sediments that are compacted and cemented together makes a sedimentary rock. You know, what processes make metamorphic rock? Well, heat and pressure is what makes the metamorphic rock. All right? Igneous rocks form from the solidification of magma. So this chart here shows you how you can get pretty much any one type of rock from any other type of rock. All right, so that is the rock cycle and metamorphic rocks.